All right, so who already has an idea of what Codemods are? Good, good. Who has used them in your code base already? All right, way to go. Oh, good. That's good. Yeah, I mean, why wouldn't you commit your code mod to the code base too? That's actually a good question. You just applied it. Okay, that's fine. Well, let's go over what they are really quickly. Jump on. If you want to follow along, which you probably don't because you're eating lunch. And I also need internet. I forgot about that. Who can help me get on the internet? Inst guest. Oh, everyone's going to see my email address. Spam@spam.spam. Good? Good. Connection successful. Security. I like that. Okay. All right, instructor. Let's go. Here we go. Splody socks. Sorry, I should have had this pulled up before we started, but I was short-sighted. Okay. Gonna play along. Cool. So Codemods are a way to use programs to transform the source code of your other programs. In short, if we want to do massive changes to our source code, which is sometimes necessary for good refactorings, we can use things like grep and sed and awk and all of our beautiful, beautiful pipeable Unix tools, which also are not aware of JavaScript syntax, and we can also absolutely destroy our code base, especially if we don't have desirable test coverage, which I know that everyone in the world except for me has perfect test coverage. But this is helpful for me because I sometimes need to make changes to my code base in multiple places, or many, many multiple places, that will work much better if the replacements are aware of JavaScript syntax, or the syntax of the language that I'm replacing. So specifically, Codemods can be applied to any language, but the tools I'm going to show you today are for JavaScript, understand JavaScript, made in JavaScript, and run on JavaScript. So how this works is some command line tool takes a file or files of source code and translates them into what's called an AST, or abstract syntax tree. And what that is a representation, basically an object representation in memory of the structure of your program. It's not necessarily the actual syntax or the characters that make up a source file, but rather it's the objects that build up a JavaScript program. So we reduce our source files down to their AST form. Then we perform some function on that AST. We modify or transform the AST. And then we use a tool to rebuild that AST back up into clean source code, which we can then stick into our previous source code with the fewest unexpected modifications possible. So here's a quick example of what this looks like. Very simply, we have a variable declaration here. This statement, when you put it into the AST form, is wrapped in what's called a variable declaration. That's what the object type is, variable declaration. And then what builds up the variable declaration are some other pieces. These aren't all the pieces that are involved, but it's a reduction and a simplification. Here on the far left, we have a variable declarator, which is the var keyword here. That's what that is. That's how that looks in the syntax tree. Oops, wrong direction. Then we've got an identifier, which is Luke. So variable declarator and identifier go on the left-hand side of the equal sign. And then we've got, oh, I did it again. And then we've got a literal on the other side, which is of type string. So these four blocks are the essentials of what make up this arrangement of characters in your source code file. When we parse it and break it down, we've got a variable declaration with a declarator, identifier, and a literal. That's the idea of how the abstract syntax tree looks once you end up with it. So here's the actual JSON representation of the AST for this line as parsed by the Babel parser, right? So here it is. We start out with a file. You can see that we've got a JSON object type file. We've got a program inside that file. And then here, what I was showing you before, we've got a variable declaration. It keeps information about where those things start and end, their actual positions in the file. And then each of these nodes can have attributes. So a variable declaration has an array of declarations. And inside that, we've got a variable declarator. And inside of that, we have an ID, which is an identifier, and that's Luke right there. And you can see that the variable declarator, the variable declaration, I'm looking for something that I found last night. Maybe it's not on here. There you go, kind var. So this is a variable declaration of kind var. We can also say kind equals let or kind equals const, right? There are different types of variable declarations. So that's an example of how we can mutate the syntax tree and get something else out of it. So, yep, there's just a quick example of what an AST looks like. So there are 4 tools that are involved in writing, there are many, many tools, but I picked 4 tools to use to run these transformations on our source code. And the primary one is JS Code Shift. We can go take a quick look at that. This is a CLI, so it's a runner that'll take a script and it'll take a bunch of source files or a directory. It'll look at all of them and apply your code mod to it in parallel and then tell you the results. And I think, this is from Facebook. So this is a great tool. And what this does is this wraps AST types, which is another repo, and recast. I'll explain those in a second. It wraps them and exposes a CLI and a convenient API for finding nodes. So if you jump over here to AST types, we can see that this AST types library is used in parsing and searching and creating nodes in the AST. And you're going to need to use this a lot, or at least I have to use this a lot for reference because the documentation is non-existent, basically, for these things. So you want to keep up JS Code Shift to learn about the API for finding nodes and for running stuff. You want to keep up AST types for learning about the API for actually building nodes and finding them. And then recast, you probably don't need to keep up in your browser, but this takes an AST and rebuilds it back up into JavaScript that's as similar as possible to the file that you are already editing and tries to change it only in the places that are necessary. Okay, great. Oh, and this is the most important one right here. The AST Explorer, which someone has fantastically and fabulously written. So check this out. Over here, I can select some part of the AST in my source code, and I can look at the actual AST on the right side. So live, it'll break down my source and show me the AST. So I can say, let's say I wanted to change this from var Luke equals Skywalker to let Luke equals Skywalker. Whoop. We can just go into the second variable declaration here and say, what's the difference? Oh, it's a variable declaration of the kind let. Pretty cool. And here we can configure a bunch of different parsers. I've been using the Babylon parser. I'm not exactly sure what the fine differences are between all of these. I know that my coworker Dallin has been using the recast parser, which makes sense. So I'm unclear actually on which one of those we should be using. You can also apply a transformation live in the browser, which is pretty neat, and we'll show you this in a second. This is the same syntax, and it'll run live that you'll use to use the JS Code Shift CLI to run transformations on all of your files in your whole code base. So this makes for very rapid development of transformation functions. So we're going to be using this heavily. Oh, and you can see here, this example transformation takes all of the identifiers, I think, and it writes them in reverse. So if we wanted to change that from Luke to Superpants, it does it live right there. Pretty sweet. All right. So here's a case study. We had Hack Week at Koalico a week ago, and my task was to upgrade from Flow. Do you know what Flow is? Everyone know what Flow is? Only a few people. Flow is a static type checking layer over JavaScript that's offered by Facebook, and we use it heavily on our project at Koali. It's been great for us, but when they release new versions, oftentimes they support new features, which means lots and lots of bugs get found in our source code, because a lot of times we've ignored, like for example, Flow 14 didn't support generators. We used them all over our code because we were using Koa as a server. So trying to upgrade to 16, all of a sudden we had over 1,000 uses of generators that we had told Flow to ignore. It no longer ignores them. It understands them now. So we have many errors to deal with. So that was the idea, is okay, I'll resolve all of these errors as we upgrade to Flow 16. So before the code mods were applied, I spent like the first 3 days of the week trying to resolve 1,495 errors, and I think I maybe got like 20 done until I was in despair and was talking on the Flow chat room, and someone mentioned Codemods. Took a look at them, and it took me, a day or so to write a few Codemods that took us to 102 Flow errors. And that's just, in a minute, then I've all of a sudden got the transformations I needed to reduce those errors. And the great thing was I could iterate on it, where before I was trying to do search and replace and I've got to search and then make these hand edits, and some of them are destructive and not easily reproducible. This way I could just run it, be like, oh, I did it wrong, destroy all those changes, make a small change, run it again, and 90 seconds later I've got the changes I needed throughout the entire code base. So that was huge. And then over the next day or so, I was able to go in and clean up the rest of the errors by hand, and made me happy. Unfortunately, we also found a bug in Babel, so we couldn't use those changes, but doesn't matter. Okay, so now let's do a quick demo. If you want to look at this later, I've got a GitHub repo at github.com/splodingsucks/lunch.js Codemods. This you can clone, and here I've got some examples. There are two very simple code mods in here. Here's a sample file that we'll use right now to do a demo. And then I've also included one of our code mod files from Koali that I wrote during Hack Week that does some interesting flow type transformations. And this is more than anything, this just contains some methods that I discovered I needed while I was working on Codemods. So if you run into the same problems, you can come in here and take a look. I wanted a way to be able to combine different streams of finding nodes and operate on those. And so this is the result of taking a few hours digging around in the source code for these libraries. But that's just for reference. It's not that useful. Okay, so let's go ahead and take this source code and let's copy it into the AST Explorer and see if we can do some fun stuff on it, okay? Here's the AST Explorer. There's our source code. And this is, oh, nice. Got some notifications there. This is the source code for Darth Vader's plan when he finds Luke finally. You can see that he's got the Force here, and he's got a library of actions that he's going to use. And I think that he runs this on that little box on his chest, but I'm not sure. I just found this online. I'm joking. I wrote it. So he's got a listener here that listens for events. So he's like, oh, when the target's close, I need to kidnap it. And this target, you can see, is Luke Skywalker. But since we've watched the movie, we know that Luke Skywalker is actually Darth Vader's son. So I think we should... oh, I'm sorry. I should have noticed everyone about that. So we're going to update the source code to be spoilerific with a transformation. We don't want to have to go through and find all of the occurrences of target by hand. We're just going to write a code mod to do it for us. So this is one I've actually done already. So we'll copy that in for reference because I still don't have this all committed to memory yet. I know, a little bit confusing. But index, oops, wrong one. Transform. All right, don't. Oh. Hold on, don't look at that second one. We're going to come back to it. The first example I wanted to show was converting all of the var declarations to let. Okay, let's see if we can make this work. Oh. And I haven't actually done this, and this is brand new live coding. I haven't done this in this browser tool yet, so I'm probably going to mess everything up. But that's okay. You can just boo me out. Oh, thank you. It's already working. Okay. So let's go over to this file here and see what I did. So we're getting in file info and API. That's what the JS CodeShift provides us, because JS CodeShift expects this file to export a function that takes in these two things, and it provides them to us. So a convention that the docs seemed to use was assigning the JS CodeShift API to a variable called j. So let's do that. And let's get the source from the file info. Those two things should allow us to translate the source pretty easily. So here we're going to say, this right here, is that what you're saying? Yeah. Oh yeah, file info to file. This is a string of the source code. No, this is not. This is this will expose to us an object with methods on it for finding nodes. That's what JS Code Shift does here. So src represents an object that'll allow us to find nodes and run operations on them. Exactly. Yeah, exactly right. And in order to get the string from it, you could say source.source, I think is what it is. We'll see in just a second here. To source, there we go. So what we need to do is return from this function the changed source. And we could just say anything we wanted here, like, for example, return Bobby. Codemods done, everybody go home. Just kidding. src.toSource. So you can see that on the right here, we have brought in our source code, done nothing to it, and exported it right there. But now we want to do that thing where we change all of the vars to lets. So we're going to say change var to let, and we're going to pass in j. We're going to pass in our source. And let's see if it worked. Yep, there we go. All the var declarations are now lets. So let's see why it does that pretty quickly. Here we come in, call change var to let. We get in our j library, which is the JS Code Shift API, and the source object. And on this source, we're going to call find. Now, once again, in order to be able to learn how to use the JS Code Shift API, you just kind of have to look through the code. And you could read the documentation. But there isn't a whole lot. There's not like an API doc, basically, where it lists out all your methods. You just kind of got to jump in and see what's available. But find should go through the entire AST. It's kind of like a CSS selector or query selector all in the DOM in JavaScript. It'll find all of the nodes in the AST of that type and give them to you in a sequence, not in an array. So that sequence has an array or has a method on it called forEach that you can call, and that passes in an object that's a path. This path holds a node in it, holds an AST node, and it also holds some extra information about that node, like who its parents are and things like that. Stuff that the node doesn't actually worry about itself, but the path gives you context that you can operate on. So what we do is we say find all of the nodes that are of type j.variableDeclaration. Now here's a quick convention that you'll find when you start to use this. If you're using node types, you can call j, which is the JS Code Shift API, and with that type, and an uppercase letter at the beginning will be an object for matching types against. A lowercase letter like that will break, because what it is that's a function that you can use to make a new node of that type. Okay, and it's not written anywhere. It's just like that's how they do it. So remember it. So we find all of the variable declarations throughout the whole AST, and then we loop over them. We get into the path, and we access the value on the path. That's a consistent API right there. Path.value always refers to the DOM node that's been found. And then let's say we hadn't written this yet, and we wanted to figure out what to change in order to actually convert a var to let. So we're going to go select var right here, and we can see that it highlighted in our AST what we were looking at. So we're going to go into there and say, okay, so the attribute I want to change here is kind. And if I change it from var to the string let, it should work. But just to be sure, let's go find this type where it's constructed in the source code and see what the arguments for the constructor are. So we're going to look for variable declaration. Look, now I have no tabs to tell where on earth I am. I think. There are my tabs. Let's go pull up the AST types repo. Okay, so we're going to look for variable declaration in here. Variable declaration, searching inside this repository. Let's find the top level call to def for variable declaration, because you can see that it's def variable declaration is called throughout the source code. But we're going to go find the place where at the top level variable declaration appears to be defined. And variable, they're right there. So we're going to call def variable declaration, and there's a field on that, or rather a method called field, and this lets us know what the construction arguments are for this type. So we can either pass in an identifier or a variable declarator, and that will construct a new variable declaration. And we can go through this source code and search for the variable declarator type also. And I may be leading us on a little wild goose chase because I haven't actually done this example yet. But I'm trying to find where it'll tell us that it'll either take var or let as an attribute, and I may not find it. So let's, in the interest of time, skip that for now and pretend that I found the thing I wanted to find and that you're all satisfied. And let's go change it right here in the source code. So path.value.kind, which we can see right here is var. Let's try changing it to let. It works. Let's try changing it to const. It works. Let's try changing it to Bob. It works. So this is JS 2018 when we have the new declaration type of Bob. Or Sally, because we're equal opportunity there. Okay. So let's leave that as let. Now let's do that transformation we wanted to do where we change target to Luke. So here we go. Function. Change target to son. Right? J source. First thing we're going to have to do is loop through and find, well, let's figure out what we're going to have to find. Let's go into our source tree here, and we're going to click on the thing we want to change. So we want to change all of the occurrences of target. So this is a variable declaration, and inside there's a variable declarator which has an identifier whose name is target. So let's go ahead and say source.find j.identifier. We're going to find all of the identifiers in the file. Identifier. And then from there, we're going to filter it because we don't want to change every identifier. We just want to change the ones that have the name of target. So we're going to do a filter, pass in a path. These are magical. They do not return arrays. They return sequences of the type that are specified in the JS Code Shift library. Yeah, which is pretty sad, but that's okay too. I mean, there are ways to get arrays out. You can call two nodes, and that'll just give you an array of nodes. But I don't think that will mutate the source tree. So it's not terribly helpful. So here we're going to filter over the different paths we get back from finding all of the identifiers. And we're going to say return path.value.name is equal to target. So now we should have a selection of only the identifiers that have the name of target. Now we could say a dot for each. It's funny because they offer both for each and map, and I can't tell any difference between them because you can just mutate in both of them. I don't know. Strange. There is probably a significant difference that I just overlooked. Okay, so inside of here, we're going to say path dot value dot name equals son. Did it work? I haven't returned it. Thank you. Return. Did it work? Dot two. Oh, you know, I haven't called the function. Woo! Woo! So I don't even need to return this because I'm actually mutating the source. So right here, change var. Oh, what's it called? Change target to son. Change target to son. J. Everyone ready? S R C. Da da da. It worked! Yay! Thank you. Thank you. No, really, I'm here till Friday. So that's all I was going to show you today. That is an extremely simple example. It gets more complicated than this. Maybe I'll show you really quickly some of the stuff we were doing at Koali. Dink. Oh, I'm so bad. I keep closing those repos that I need. Here you go. Exploding socks. JS Codemods. Other examples. There we go. So inside of here, we do some interesting stuff. Like you'll see we come in, and what we wanted to do is we wanted to take all of the yield statements in our source code, which were over 1,000, because we had generators and we had yield inside of those generators. And we wanted to assign them, or we wanted to wrap them in a typecast statement for flow. So we would find all yield expressions in the source code, filter through, and I had to make sure that the parent, so here we can start to get some more complex stuff. The rule is only take yield expressions whose parent is a variable declarator or an assignment expression. Yeah. Yeah, I apologize. And this was because there were yield statements that shouldn't have been cast that I was typing. So I had to come through and say, be more specific. I only want to find the yield statements that have a parent, a variable declarator, or assignment expression. And then I'm going to wrap them in the typecast. And what this basically does is this just says, hey, take this node or this path, generate a new path inside, and completely replace this path with that path. Or basically, we're just swapping out nodes in the AST. And let's look at wrap yield and typecast really quickly. So here we get a yield expression. So this is nodes. These are nodes that make up a yield expression that already exists. And then we're going to construct a new typecast expression. You see here a lowercase t. That's what I was referring to earlier. We're constructing a new typecast expression by calling the type name with a lowercase letter at the front. And then we're passing in another new type, which is a parenthesized expression. And then we're inserting our previously existing yield expression there. And then we're giving it a predetermined type. So what this does is this creates a new set of objects with the correct types for the AST and inserts our old code inside of it. Because we wanted to say, just take this existing statement and wrap it in a typecast expression. And it worked quite well. So there's an example of how to use Codemods. That's it. Thanks. Yeah.
How do you then take this to something you need to do in your production code? Like, is there the ability to say, run this on any files in this folder?
Yes. Yeah, I'll show you. In fact, if you clone down the repo, the Codemods repo, I've just got it installed as a dependency right here, JS CodeShift, and then it offers an executable that then you can pass in. By default, it looks for the transform.js file, but you can pass in a file that specifies your transformation you want to perform, and then you just pass in a directory name, and then you can also tell it what extensions to monitor or use and what not to. And then it's pretty neat because it'll start up and it'll parallelize, like you can specify the number of cores you want to take up. Mine, it would do like 7 parallel processes, and each of them would take like 50 files, and they would crunch on it for 90 seconds. And then at the end it says like this many were modified and this many were unmodified and this many changes were made. It's pretty awesome. Any other questions? All right. Yeah. No, the AST is per file. So this script is limited to the scope of the file that it's running on. Yeah.
How much of, like, I don't know, comments, white space, mutating, things like that have you seen going back the other direction? Like, does it really screw with your formatting?
It's a great question. I am very surprised by how little it screws with the formatting. I did write a code mod to take out comments, and it's funny because we use no semicolons in our project by convention. And when I took out the comments, it would actually insert a semicolon on the line below the comment. And that was just because of the way the reconstruction library worked. They assumed semicolons everywhere. So when I ran it, I actually just went into the node modules folder and hacked and just like deleted all of the semicolons from the reconstruction project. And it worked great. But that was one example. Another one is Dallin was just writing a code mod, and it was when he tried to replace a node, it was like stripping a whole block comment at the beginning of the file. And that's because comments are attached to AST nodes, and if you like nuke a node, then all of its parents will get killed, and comments aren't considered a reason to keep a parent around. So there is some weird destructive stuff that happens, but overall, I've been very impressed with how consistent and how non-destructive the reconstruction from the AST is.
Does it, like, assume a particular linter that you use, like, as far as where curly braces and stuff like that go, or
It doesn't.
or whatever? I mean, does it take all that?
It doesn't take any of that into consideration as far as I know. So there were some cases in our replacements that I found where we had actually written things out that weren't according to our style guide, and it fixed those. So I don't know if that's because we write perfect JavaScript, which is probable. No, just kidding. Or if it's just because it may have been inspecting the state of our code or some of our conventions, but I doubt that it's that intelligent. So you may end up with some strange things. Yeah, Dallin.
You can pass in an options object with the recast library for, like, do you want filling commas, or you want single double quotes. There's quite a few options, but it doesn't have everything that ESLint has.
All right, just for the people watching on the video, Dallin said you can pass in options to configure recast, but it doesn't have all of the options that ESLint has. Yeah.
Also, ESLint has a fixed option for many of the rules that it handles. It can modify the code as well.
Oh, really? That's very cool. ESLint can reformat your code. So maybe a two-pass approach would be great. First you reformat it, then you run ESLint on it, and it cleans up the other stuff. All right, everybody. Thank you so much for your time. Appreciate it.